The second half of 3.4 is on logarithmic equations. We're starting with example 0 because this is using something that your book has already shown you, the one-to-one property. So if you have the log base 3 of x minus 7 equals log base 3 of 5, since they are both log base 3, it must be true that their arguments are equal to each other. So x minus 7 equals 5 or x equals 12. Again, just do a visual check. If I plug in 12, 12 minus 7 is a positive 5. That's a fine answer. Okay, now starting with example 1. When there's not a log on both sides, you often have to rewrite it into exponential form in order to solve it. Okay, so to write this in exponential form, the base is 2. The exponent's negative 3, so that's equal to x. And then I just want to simplify my answer. This is 1 over 2 to the third, so x equals 1/8. Okay, for example 2, log base 8 of 1 over 32 equals x. Again, I'm just going to rewrite this in exponential form. The base is 8 to the x equals 1 over 32. And then I have to decide how I want to solve this. Because I can see I can do a common base, I'm going to do a common base because that's the most efficient way to get an exact rational answer. 2 to the third is 8, so 2 to the 3x. 2 to the fifth is 32, so 1 over 32 is 2 to the negative 5. Because they have the same base, one-to-one property says they must have equivalent exponents. Okay, so I got x is negative 5/3, that's fine. It has no effect on the argument. Okay, next one, ln of x plus 5 equals 1/2. I'm going to rewrite this in exponential form because it's a natural log. The base is automatically e, so e to the 1/2 equals x plus 5. 1/2 is really the square root of e, and that's a nicer way to write it. Okay, and then I'm going to subtract the 5 to the other side. The square root of e minus 5 equals x, and that's a nice exact answer. If they asked you to put it in your calculator, you could. If they don't ask you to put it in your calculator, you wanted to leave it in the most exact form possible. Okay, now starting with example 4, there is more than one log on the left side. So before I rewrite this in exponential form, I have to combine them into a single log. Okay, so the log of 3 plus the log of x minus 1, since I'm adding the logs, I am multiplying their arguments. Now that I have this rewritten as a single log, I can rewrite this in exponential form. Since this is the common log, the base is 10. So what would this be? This would be 3 times x minus 1 equals 10 squared. Or you could rewrite it the opposite way. So 3x minus 3 equals 100. I got 103 over 3, and then I did glance and see if I plug in 103 over 3 here, will that maintain a positive argument when I subtract 1? Yes, it's fine. So for the next one, again, there's more than one log being added or subtracted, so I need to combine them into a single log before I do exponential form. They are both base 3, so that's good. Log base 3, since they're subtracting the logs, I am dividing their arguments. Okay, so let's see. 3 to the second equals 4x minus 5 over x. I'm going to multiply the x. So I got x equals -1. I'm going to glance up and see if that's going to make any of my arguments negative. Oh yeah, that's a problem. So x actually cannot equal -1, which means this thing has no solution. Okay, the last problem is a natural log, but again, I need to combine them in a single log first. So let me rewrite this as the natural log of x times x minus 5. Now I can go ahead and make this exponential form. Because it's natural log, the base is e. So e to the third equals x times x minus 5. I'm going to distribute this. Okay, so this is a quadratic. I'm pretty sure I'm not going to be able to factor this, but I'm going to still set it equal to 0. Okay, as ugly as this is, actually it's not that ugly, it's a beautiful little quadratic. I'm going to solve it using the quadratic formula. If the middle term had been even, I might have completed the square, but since it's odd, I'm going to go ahead and quadratic formula it because I can count on that to always work. Okay, negative b makes this positive 5. Let's see, b squared is 25 minus 4 times a times c all over 2a. Okay, let me simplify this. Okay, for simplification, that's about the best I can do. That's a pretty nice answer. And rough as it is, I still need to consider whether there might be an extraneous solution here. Okay, let's consider the plus first. Okay, if I do positive 5 plus the square root of this, I'm going to get a positive, and then if I divide by 2, it's still going to be positive. So it should be okay. Now if I do 5 plus something, and then it's 5 plus 25 plus something. This is going to be 5 plus, I'm going to have to make scratch work on here. So this is 5 plus 25 plus something. This is bigger than 5. 5 plus something bigger than 5, and then I divide by 2. That'll be safe to plug into here. Okay, so I definitely know that the plus answer does work. Let me write that down. X equals 5 plus. Okay, now let me consider whether if I put a minus sign there, if it will still work. Okay, now if I do 5 minus something bigger than 5, I'm going to get negative something. Divided by 2, it'll be a negative something. So if I plug that in right here, or if I plug it in here, I'm going to end up with a negative value, which is not going to work. So even though I solved and got 2 answers, the only valid answer is the one with the plus sign.